Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Kropki Drops by Michael Lefkowitz, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. A white drop indicates how many digits in the indicated direction differ from it by 1. Okay, so that means in this indicated direction. Interesting. If there were... So, in this direction, you can obviously only have as many digits as you have digits along the direction indicated. So this could be 3, and this would be then 2, and we could have like 4, 2, and 4 here. And that would be possible because along this indicated direction, the white drop indicates how many digits in the indicated direction differ from it by 1, right? There are 3 digits in this direction which are different from 3 by 1. So that's how these white drops work. The black drop indicates how many digits in the indicated direction are double or half its value. So this is why it's called Kropki drops, because they are similar to Kropki dots in the sense that there's a ratio or a consecutiveness between digits along the path and the digit in the drop itself. So say we could have actually 4 here, and then this could be 2, 8, and 2 and 8. So this actually would work in this situation because 3 of the digits along this path are 1 away from 3. 4 and 2 are both 1 away from 3, so all 3 of these satisfy it. And along this path, we have 4 digits, which are in half or are in basically a 1-to-2 ratio with 4, right? 8 is a double of 4, 2 is half of 4, and all of these fulfill that criteria. So that's how that black drop and the white drop works. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. This is at most 4 digits, so this is 1 through 4. This is at most 3 digits, so that's 1 through 3. In a row or column, you have at most 1 or 2 digits, which can be consecutive or in a 1-to-2 ratio with it. So this has to be 1 or 2. This must be 1 or 2. This has to be 1 or 2 because it can go only 2 this way at most. So this is 1 or 2. This is 1 or 2. We have 1 or 2 here. These are not on the rows. So these are diagonals. This is at most 5, but we can never have a 5 in a 1-to-2 ratio with another digit. So therefore, this is 1 through 4. This has to be 1 through 3, because that's the only number of digits it points to. This points to 1, 2, 3, 4, 5, 6, 7 at most. So this cannot be 7. It's basically 1 through 6. And can it actually be 6? And it can't be 5 here, because again, 5 is not in a 1-to-2 ratio with any digit. If you have 5, you get 2.5. If you double 5, you get 10. So 1, 2, 3, 4, 5, 6, 7. can you actually have 6? This can't even be 3, so you could have 3 here, 1 3 here, and 1 3 here. That's not 6. So this cannot be 6 here. Can you have 3 here? If you try to have 3 here, the problem with that is if you have 3 here, that means you need 3 6s along this diagonal. But you can only have 1 here, and you can only have 1 here. So this cannot be 3 here. How many digits does this see? It sees up to 8. So this could be actually up to 8 here. But can it really be 8? If we have 8, that means all of these digits are consecutive with 8. But only 2 out of 3 can be here, and only 2 out of 3 can be here. So this actually can be at most 6 digits that are consecutive with this digit. This one is 1, 2, 3, 4, 5, 6, 7. But this actually could be 7, and it's 3 through 7 here. It could be 1, 2, 3, 4, that's valid, 5, 6, 7. All 7 of them could be consecutive with 7. So that's possible. Interesting. You could have 3 6s this way. That's possible. Can you have 3 6s this way? Yes, that's also possible. If this is 2, the problem with that is in this column, that would mean 1 and 3 would have to be here, but that would eliminate all possibilities for this cell. So this cannot be 2. This has to be 1, which means 2 has to be consecutive with it somewhere here. So this can't be 1 or 2, it's 3. So all 3 of these are consecutive with 3. So these have to be 2, 4. Therefore, we have a 2, 4 pair here. This is 1. That's interesting. This can't be 3 anymore. So it has to be 4, 5, 6, or 7. Okay. We have a 1 there. Huh. So this can't be 2. It can't be 1. It's 4 through 9. Oh, this has to be a 2, right? It can't be, well, it could be 1 or 2. No, either of those work. Interesting. If this is 1, both of these become 2. And therefore, if this is 1, that becomes 2, that becomes 2. These 2 must be consecutive with 2. So this would be 3, this would be 1 or 3. But then this would have to have 2 digits here in this column consecutive with 2, which means this can't be 1 or 3. So this cannot be 1 here. It's 2 or 4 here. Interesting. If this were 2 here, that would force this to be 1 and that to be 1. So this would have 1 in that direction be consecutive with 1. This can't be 2, so this would have to be 2, but then this requires a 2 to be in this direction to be consecutive with 1 once. And that's not allowed because of the 2 there. So this can't be 2, it's 4 then here. So we have 4 instances which are in a 1 to 2 ratio with 4. Interesting. This can't be 4 here. Remaining digits of box 3 are 1, 3, 5, 7, 1, 3, 5, 6, 7, 8, 9. No 1s here, no 3s here, obviously. So that's kind of interesting. Hmm. Um... This can't be 3. If this were 3, these would all be consecutive with 3, but we only have 2 digits consecutive with 3 out of the digits 1 through 9. So this is not 3, it's 1 or 2. So this is a 1, 2, 1, 2 pair here, interestingly enough. Remaining digits in this column, then, are 3 through 9. Obviously, 4 cannot be here. Remaining digits in this box are 3 through 9. No 4 in this column. That means these are the same digit, right? Because this is 1 or 2, and this is the 1 or 2. So if this were 2, then these would have to be consecutive with 2, which would be 3 and 4. And these would have to have 2 consecutive with 3 and 2, which, sorry, 1 and 3. So if 2 were here and 2 were here, these would have to be 1 or 3. But 2 out of these 3 would have to be 1 or 3, and that would be too many 1s and 3s in this box. So this cannot be 2. Therefore, these are the same digit and are 1. That makes this 2 there. This can't be 2, so that's 4. That eliminates 4 from being here. 3 and 1 must be consecutive in this direction, so this cannot be 3 here. This is 1, so there must be 1, 2 here. There must be 1, 2 here. So we're guaranteed this one of these 3 is 2, which means this can't be 2, that's 1. This can't be 2. So where is the 2 in this direction that's consecutive with the 1? It has to be there, which means that's 2. This is 2. This can't be 1 or 2 anymore, so it's 3, 5, or 6. 1 eliminates 1 from being here and here. 4 eliminates 4 from being here. Okay. Interesting. What else do we have? 1 has to be one of these 2 digits here. Remaining digits of row 8 are 3, 5, 6, 7, 8, 9. No 3 here because of 3 in the column. Four has to be one of these 3. Four. Can this actually... This could be actually all 4. Right, you could have 8 here, 4 with 2 or 8 here, 2 here, and then 8 here. So that's possible. 2 is consecutive with 1 and 3 this way. 1 is consecutive with 2 in one of these cells. 1 is consecutive with 2 there, then. 4 has to be in a 1 to 2 ratio with... there we go. With 4 digits here, and these are all 1. So this cannot be 4, it's 2. This must be 8, and this must be a 2-8 pair here. Which eliminates 2 and 8 in the rest of the box, so this can't be 2. This is 3 or 4 here. Well, this 2 means this can't be 2 here. That's 4. That means this is not 4 digits which are in a 1 to 2 ratio with 4, so this must be 3. Which means this has to be in a 1 to 2 ratio with 6 3 times. So this is 6 here. That eliminates 6 and 8 here. No 6 and 8, no 6 and 8, no 6 and 8. So that's satisfied. This 3 is satisfied there. The 4 is satisfied. This 3 eliminates 3 here, so that's 2. Well, this could be 1. We don't know. 1 can't be here. 1 has to be... 1 can't be here, 1 can't be here, 1 can't be here in box 5, so 1 has to be there. This can't be 1 or 4, so that's not satisfied. This can't be 1 or 4, so that's not satisfied. We have 2 out of these. This can't be 1 or 4, so none of these can be satisfied to be in a 1 to 2 ratio, right? This can't be 1 or 4 because of 1 or 4 in the row. This can't be 1 or 4 because of 1 in the column and 4 in the row. This can't be 1 or 4 because of 1 in the row and 4 in the column. Also, since this is 4, where is the 4 in box? Oh, box 9. 4 has to be here. 2 eliminates 2 here, so that's 1. That means this is no longer 1 there. Again, these can't be 1 or 4, so this must be 1 or 4 here. This can't be 1 because of 1 in the box, so that's 4. This can't be 1 because of 1 in the column, so that's 4, which eliminates 4 in the rest of the box and column. 6 eliminates 6 here. These can't be 6 either because of 6 in the row. These can't be 6 because of 6 in the column. Okay, no 4 or 6 here because of 6 in the row and 4 in the row. No 6 here because of 6 in the row. Can this be 7 still? Maybe. Can this be 6 though? That means, well, on this diagonal, 6 is not consecutive with 6, and 2 and 8 is not consecutive with 6. That leaves 1, 2, 3, 4, 5 digits at most, which can, if this is not 6. Sorry, if this were 6, so this can't be 6 here. It's 5 or 7. 2 eliminates 2 here, so that's 8 and 2. Both of these are consecutive with 7, so 7 is still satisfied there. 8 eliminates 8 in the rest of the row and column. This 6 eliminates 6 in the rest of the column. 2 eliminates 2 here. So along this diagonal, there must be 1 consecutive, so that's 2. So this is satisfied. This is satisfied. This is satisfied. 1 is consecutive with 2. That's satisfied. 3, 5, or 6. Interesting. Three is only consecutive with 2 and 4. 2 can't be here. 2 can't be here. And 2 and 4 can't be here. So 2 and 4 can't be here. 2 and 4 can't be here. We could only have 1 digit that's consecutive with 3 here. So this cannot be 3 then. It's 5 or 6. Interesting. Can we have 5? 5 is only consecutive with 4 and 6. We could have 1 here. We could have 1 here because we already have a 6 here. And we can't have any here. So the 5 doesn't work. So this must be 6. Which means this has to be a 5-7 pair here to be consecutive with both of these. 5 and 7 have to be both here to be consecutive with this. And we need two 5s and 7s here. So this cannot be 5 or 7, it's 9. This can't be 5, 7, or 9, it's 3, which eliminates 3 and 9 in the rest of the box. So this is 1, 5, and 7. And that satisfies 6 there. 6 eliminates 6 here and 6 here. Where is 6 in row 6? Can't be here because of 6 is in the boxes, so they have to be here. That eliminates 6 in the rest of the column here. This 5-7 pair eliminates 5-7 in the rest of the box. So this is 3, 8, and 9 left. This 5, 7 eliminates 5, 7 in the rest of the box. So this is 4, 9 left. This can't be 4 because of 4 in the row and column. So that's 9, that's 4 here. That eliminates 9 in the rest of the row. We have a 5, 7 pair in row 4, which eliminates 5, 7 in the rest of the row there. So this can't be 5 or 7. It's 3, which forces this to be 1. There's no 1 here. So where's 1 in box 3? It must be here, which means this can't be 1 in column 1. So where's the 1 then in column 1? It must be here. So this 6 is satisfied now. 2 is satisfied with 1 and 3. 1 is satisfied with the 2. 2 has 4 and 4, so that's satisfied. Okay. 2, where is 2 in column 5? Has to be one of these two here. Where is 2 in column 1? It must be one of those two there. Where is 2 remaining in column 9 then? Can't be here. Can't be any of these because of 2 is in the boxes, so 2 has to be there. Can this actually... Okay, we have a 5, 7 pair in column 2, which eliminates 5 and 7 in the rest of the column. What is the remaining digit? We have a 3, 8, 9 triplet in column 2, which eliminates 3, 8, 9 in the rest of the column. So this can't be 3, 8, 9, it's 4. 3 eliminates 3 in the rest of the box and column. Where is 6 in column 3? These already have 6s in the box. This can't be 6 because of 6 in the row. So 6 has to be here. That leaves this as 5, 7, 8, 9. Where's 3 in row 2? Can't be here because of 3's in the boxes. Can't be here because 3 in the column. So 3 has to be here, which eliminates 3 in the rest of the column here. This is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the box. This can't be 8 or 9. It's 3. It also eliminates 8 and 9 in the rest of the row. So remaining digits must be 3, 4, 5, and 7. Well, this can't be 4 because of 4 in the column. No 3 here because of 3 in the column. No 3 or 4. No 4's here because of 4's in the column. No 3 here because of 3 in the column. So where's 4 in row 9? It has to be here. So that's 4. This 3 eliminates 3 from being here. No 3 here because of 3 in the column. No 8 here because of 8 in the column. No 9 here because of 9 in the column. Remaining digits of row 6 are 5, 7, 8, 9. Remaining digits of row 7 are 5, 6, 7, 8, 9. No 8 here because of 8 in the column. No 8 here because of 8 in the column. No 9 here because of 9 in the column. No 6 here because of 6 in the column. Okay. Where is 3 in column 4? It has to be here. So 3 eliminates 3 here. We have a 5, 7 pair in box 9, which eliminates 5, 7 in the rest of the box. And a 5, 7 pair in column 8, which eliminates 5, 7 in the rest of the column. 9 eliminates 9 here. That leaves this as 3, 6, or 9. It cannot be 6 because of 6 in the box. Where is 8 in box 9? It must be one of these two cells, so it cannot be 8 here. Remaining digits of column 4. 5, 6, 7, 8. No 6 here because of 6 in the row. No 8 here because of 8 in the row. Can this actually be 5? This digit is not consecutive with 5. Neither is that. That's 2. Neither is that. We have 1 only here and 1 only here. So this cannot be 5. This has to be 7 digits consecutive with 5. Or sorry, 7 digits consecutive with 7, which means this can't be 5, 7, or 9. It's 8. This can't be 5 or 7. It's 8. This has to be 8. This is 6 and 8 there. That leaves this as 3. This is 9. No more 9s here. We have a 5, 7 pair. This 8 eliminates 8 here, so that's 9, which makes this 8, which makes that 9. 7 eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 7, which eliminates 5 and 7 here, so it's 6. This can't be 6 or 7. 8 here eliminates 8 here, so it's 5, which makes this 9, which makes that 8. 5 eliminates 5 here, so it's 7 and 5. This can't be 5, 7, or 8. It's 9. 7 eliminates 7 here, and this can't be 5, so this is 6 here. We have a 2, 5 pair here. So 7 is filled. 9 eliminates 9 here, so it's 3. No 8 here. This is 5, 7, or 9. 7 eliminates 7 in the rest of the row. No 7 or 8 here. It's 5 or 9. This is 5 or 7. 8 has to be one of these two. This can't be 7, 8, or 9. It's 5. So that leaves this as 7, this as 9, and this as 8. This is 2, 5 as a pair, which eliminates 2, 5 in the rest of the row. Right? Oh, this could be 2, 5, or 7. So no 2 here. This is 2 or 5. This is 2 or 5. 5 eliminates 5 here, so it's 7, which makes this 5, which makes that 7. 5 eliminates 5 here, so it's 2 and 5. This can't be 2 or 5. It's 7, which makes this 5, which makes that 2. No 5 or 7 eliminates 5 or 7 there, so it's 9, which makes this 5, which makes this 7, which makes this 5. And that's the solution. Pretty cool use of these Kropki drops. In the end, it was kind of similar, actually, to the example I was giving. But I didn't really know if that was the case. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.